Before joining ALICE, I have been involved for many decades in experiments at CERN, where I happen to be involved in rather big experiments in the development, construction and running of big experiments. That was one aspect I thought was useful for ALICE. The second point, which I thought was helpful, was the fact that I was involved in the 1980s in the development of the first phase of the CERN relativistic ion program, and therefore I knew many of the collaborators who were working in ALICE. I knew from this period. In particular, just joining ALICE, I was working during the 1990s in ATLAS. There I was one of the persons who initiated the development of this very big ATLAS muon spectrometer, the biggest spectrometer ever built. I was involved in the conception and in the development of the instrumentation. And it was sort of a natural point for me in my career, where I always tried to change my focus every 10 years or so, to switch. The work in ATLAS came to the point where the construction of the instrumentation was going well, and I felt ready for a new shift in my career focus. When I was approached of joining ALICE as a technical coordinator, I thought, of course, carefully about it, but as I mentioned, my past background in building large experiments and knowing the community, and the fact that I felt I had done a major piece of work in ATLAS, meant to me that time was right to consider this. And I also felt that having been involved in ATLAS, which started work approximately 5 years earlier than ALICE, I could bring some of the experiences I learned in ATLAS to ALICE. And therefore I considered carefully the things which went well in the ATLAS technical coordination and how I could adapt them to the ALICE technical coordination. In addition, there was one point which I find intriguing and challenging, namely that, typical for the heavy ion community, it consisted of two different communities. There were the nuclear physicist community and the particle physics community. And I thought I understood, having worked in both communities, I understood both communities, and I would also bring this understanding to the ALICE technical coordination. So what I tried to do were several things. I tried to adapt what I learned from ATLAS to the somewhat smaller community of ALICE, and also to recognize these different communities and trying to bring to these communities a unified approach to building up the experiment. So my plan was to help the collaboration by providing a frame for the development and construction work of the detectors, but also using this activity to strengthen the collaboration spirit of the collaboration. You must realize that during this time from 2001, when I joined ALICE, this was the time where the experiment was shaped and the detectors were built, and this was the center of activity, and therefore this development and construction activity was the most useful way to building up the spirit and the collaboration. Okay. Controversies, of course, in a large community of scientists, you have fortunately a broad spectrum of opinions, which one had to listen to and trying to find a unified approach. When I joined ALICE, certain features were still not defined, and one of my first realizations and interest was to work with Alice to develop a concept for triggering. The heavy ion community had sort of an approach of that every collision was a useful collision, it's a little bit the nuclear physics style. And of course it became clear this would not be acceptable for the Alice program. So one of the very first initiatives was to look into the concept of how Alice could be triggered, how the experiment could be triggered. And that was a very interesting development, and there of course many people had different ideas. The triggering is extremely hard, and therefore everybody has his approach. And I found this very useful to work with the collaboration and to develop a concept which I think turned out to be quite successful. The other point was my realization that when I joined, Alice had no concept of a colorimeter. It had this very good photon detector, but this was a small dedicated device, and therefore I worked with the collaboration to make sure that at least the possibility would be kept open that later on a colorimeter could be added, which actually happened. So controversies, no, but interesting scientific discussions with the collaboration on certain aspects of the experiment and how to strengthen the physics and discovery potential of the experiment. Alice actually made an interesting development. It was not at the beginning the very prime goal of the LHC program. This was BP collisions at the highest energies and highest luminosities. So Alice had to do a lot of convincing of the CERN management and the scientific community that this was a program very important in its own right and that it would deserve the appropriate support. It really became a powerful program once the concept was established with the L3 magnet as the central piece of the equipment inherited from the lab era, which put Alice on the experimental real plane and also made it a very important contender and partner in the LHC physics program. So for me it was quite interesting to observe this evolvement, and so Alice always was sort of a little bit the underdog in the LHC program, and I guess it was important to realize this and that Alice had to do this kind of missionary work in the community to get its proper place in the LHC program. And in retrospect, I think this was extremely successful because Atlas and CMS developed slowly some very strong and competitive heavy ion programs, showing the importance of the program and also strengthening overall the scientific output of this program. So this was a little bit the development and the role Alice had to take, and I think it did this very successfully. But once it was established, the CERN management was extremely supportive, was very supportive, because it realized that this would overall strengthen the global LHC program. Safety, of course, was one of my prime responsibilities and one of my principal concerns, obvious. Safety took on, for all experimental physicists, a new dimension with LHC. And for Alice, there was an added point which required attention. In the Alice experimental hall, the radiation is not as strong as in the Atlas and CMS halls, and therefore Alice took the advantage of locating lots of electronics in the experimental hall, which from a technical point was an advantage. On the other hand, from the safety point, it was an additional burden because electronics means power supplies, and we know that power supplies have a tendency to fail, sometimes to burn. So one of my principal concerns always was to make sure that this would not happen, because when the experiment was in operation, you could not, of course, access these electronics, so you had to be sure nothing would happen. So I developed a habit of walking around every day in the cavern and listening to the electronics, because I believed I could acoustically detect incipient problems with the electronics and the power supplies, and I developed a fine ear to listening, and I could detect troubles just by walking around. So I developed this, and so far, luckily, we were safe. Nothing happened. Of course, also in the assembly, one had to be extremely careful. So people had to take training courses how to work at elevated heights, which we all took. One had to be vigilant, but we also were helped by professional staff who were responsible, of course, for safety issues. And there we had a small safety team who did an excellent job, a proactive job in making sure that things would work and the installation would respect the safety problems. And thank God we never had a serious problem concerning safety. So it was always very up on the agenda, and of course always also at the highest CERN level appropriately discussed, given its important difficult moments. As you can imagine, in the development and construction there are always some unforeseen things which happen, never actually endangering the experiment, but we always had to deal with surprises. I believe this is part of the excitement of being a physicist, that every day is new and every day you have some surprises to deal with. Some take more than one day to solve, some can be solved quickly. We had some difficult moments, but I always had the impression that the collaboration worked well. The collaboration had one common goal on making ALICE work, to build ALICE and make it work. And therefore, difficult moments were shared and were solved within the appropriate collaboration. So, yes, exciting moments, difficult moments, but never, I felt never to be overwhelmed by the difficulties. Now, there were many also beautiful moments. I remember the first time we switched on the TPC. This was, of course, the centerpiece of the experiment when we installed the first detectors. Well, there, that was sort of amusing. People got attached to the detectors they were developing over many years, and they were almost afraid to let go and install them in the experiment. So the biggest difficulties I had actually convincing my collaborators that your detector is working perfectly. Now time has come to move it from the laboratory to the experiment. So this was actually psychological trauma for some of my colleagues, to give the baby away, okay, to put it into the lab of the ALICE collaboration. But of course this worked, and I think the most exciting moment was clearly when we had the first collisions and we saw the first tracks in ALICE, and I think this was, an absolutely exciting moment. I worked for 20 years on the LHC experiments, and to see it happen, and to see it happen as planned and as worked on, was just an incredible emotional moment and an extremely happy moment in my professional career. Well, my wishes are obvious. ALICE had a wonderful use, It is now has reached maturity. It will develop as all mature persons, and this collaboration is a very strong, wonderful collaboration where I have seen also a lot of direction in the development of the next phase of ALICE with the upgrade. I think personally that we have now reached in the physics research, FABJAN physics research, a level where we finally, I believe, come to the point where we're going to learn fundamental physics. So ALICE is now on track, on course, particularly also now with the upgrade program, to enter into this physics phase, which we started at CERN in 1980, and where naively we thought, well, within 10 years we would learn all we want to learn about the quark-gluon plasma. Now I am convinced that we have gotten the tools, but also the physicists have reached a stage in the research where we now see how we really can learn the fundamental physics, and where we can finally start to understand the properties of the primordial matter of the quark-gluon plasma. And I think this is an exciting prospect for ALICE for the next 20 years.